you do have to know how to convert the points. You have two sets of equations. One when you're going from polar to rectangular, we just call it rectangular, that's your xy points. And one from your rectangular to your polar. So we had these two, x is equal to r cosine theta, that's over here, and y is equal to r sine theta, which makes sense. The y goes with the sine, the x goes with the cosine, and you need some kind of radius in here to graph. Okay, as soon as we get to graph today, you'll actually see a polar graph, and it'll make sense to you. When we put your mode into polar, instead of the y equals or the x1, the y1, you're going to get an r equals, because polar is making constant circles all the way around. So you're just going to plot with a radius, basically. So it'll make more sense when we actually turn it to an equation for these guys. So everybody okay with this? Finding the cosine and the sine? Pulling together your point? Well, we'll get to the negative one. This guy, he's at 270, remember? Down here. 0, -1, x, y, cosine, sine. And these work off your calculator too. You can just say the sine of 270, cosine of 270. You can get it that way. The only ones you have to watch out for are the ones that are radicals. So if it's going to give you an irrational, like 1.414, blah, 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 then you got a radical. Number 3, again, when you plot these points, it gives you a good clue where this is. If this is on the 4th circle down here, I can pretty much see what my point is going to be. This one here started out like this. You can't plot a negative point. You can only plot the positive point. So that point has to go through that hole. So to make this, and if you use your graph, you can probably see where it's going to go. But to make this into a positive point, we have to apply the rule. You change this to 1, then you do 5 pi over 4 plus or minus pi. So if you just do the, God bless you, 4 pi over 4 and subtract it, you get pi over 4. So this is what we're looking at, this point. So when I graph this point somewhere over here on the 1 circle, pi over 4, it's going to be up there somewhere. So when I get to this, it makes more sense for me to be up in that quadrant. Both of those are positive. You probably had the same thing, you just had you had it in this quadrant down here. So you probably had both negatives. If you plotted the negative, right? You probably did both negatives. But you can't plot a negative point. You can only plot a positive point. So just be careful of that. Anything on the 0, remember we talked about this yesterday, anything on the 0 radius is at the pole, is the origin, is at the pole. No matter where it goes to, what the radius is here, so you're at the pole. Stop me if you have any questions. Again, the same type of thing, but your angle here just goes negative. Your angle goes down this way. So your point's going to be down here somewhere. So my x has to be positive and my y has to be negative. It kind of helps me out for like getting to know that this is good. Again, plug the parts in. You can even do this part in the calculator because these were good except for this guy. And some of them you probably recognize when it says 0.866, radical 2 over 2, 1.4, radical 2 over 2. Again, this one, make sure you switch this through the pole. Make this be a positive. So you're going to change this, and you're going to do 3 pi over 4 plus or minus pi. So again, 4 pi over 4, subtract it, and it'll come out to pi over 4. Oh, that's a negative sign. Sorry, my arrow was written right over that. So if I added this, it would come out to be positive.
You don't subtract it?
Oh, you can add or subtract it, but then you're going to come to the same point regardless because you're going to be negative 7 pi over 4 is going to put you still here. So you might as well just give it the positive. It's the same angle. You're the same angle regardless. Either you're negative 7 pi over 4 or you're pi over 4. It's the same point. Yes. Don't ask me why. Radical 2 over 2, it's an algebra thing for me. I'm always rationalizing that one. And no, you don't have to. That's the only one I constantly rationalize. I think I taught Math B and Algebra 2 for so long that it's just in my brain. Are we okay with this so far? Are they that bad?
I thought I was.
Yes, they're not bad.
I always got number 6, but I didn't change it to a positive point.
Uh-huh. But if you plotted this, where did you plot this original point at? Where did you plot that point?
I just didn't.
You didn't.
Yeah.
So,
I thought you can't plot it.
so when you came here, that would have thrown you off. You would have been over here somewhere then, with a negative 3 pi over 4. That would have forced these both to be negative.
That's what I did.
They didn't come out to be negative?
No, because I plugged
Yeah, mine
in
did
the
come out
negative
negative.
ones. I got it.
You plugged, because you plugged in the negative 1. Okay. Yeah. But really, you have to plot, it worked out the same for you, but yeah, but you shouldn't. Just because we can't do a negative.
Number 8, why did you change 5 pi over cosine 5 pi over 2 to 0?
Because 5 pi over 2, where do I find 5 pi over 2? This is 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. It's the same as up here. So this is 0, 1. So this is your x, your y, your cosine, your sine. So it's still going to be up here. This makes your radius a whole lot bigger. So I'm at the 0 for x, and I'm at the 32 for y. You can almost see it as soon as you plot that point. Everybody okay with the one over there too? 0, you're at the 0, 0, you're at the pole. Okay? Going to rectangular, from rectangular to polar, it's really, really helpful for you to plot these points. Because when you plot the points, that's your x and your y. And just like it will be the slope of your line when we do the equation, it's the tangent right now, the x and the y. So you have two things to do. You have a circle formula to find the r, which is off here somewhere.
Wait, I got the radical 2 times before. I didn't get it. Yeah, I didn't get it.
Okay, we'll get your negative radical 2 in a second. This is r. This is what you're going to, right? So if I plot this point, I'm over here, 1, 1. How did I get the negative radical 2?
I got radical 2 with the
It's just plain old radical 2. Don't ask me why this is negative.
So why is it 5 pi over 2? Yeah, I got 5 pi over 2.
Yeah, I got pi over 4. You're great.
I know why. This is separate. Wait, hang on. You don't have these directions. Hang on. This is what you got up to here, right?
Yeah.
Okay, originally in the book, because I copied these out of the book, originally in the book it says after you find this, name it one more time with a negative. So then I reversed this, so I had to add pi to it. In the book's directions, it says convert it to polar and then give it one more name. That's what the directions said. But when I copied it to the worksheet, I didn't put that. I just put this. So you don't need this part down here. This is because I didn't copy the right directions. And I didn't really need you to give it another name, so. Like last year, when they didn't want to take the book, I was copying and pasting constantly. So I just didn't copy the full directions down. This is just the same as this, but named to another point. That's all. Named to the negative point. A point through the pole. That's why each of these has 2 points on it. You only have to do the one. Yes. And you can kind of tell when it's right here, right? If I superimpose my circle, isn't this at pi? All right. There's going to be 2 points on all of these probably. Yeah. Just ignore the second point. 19. Don't worry about 19. I really like you to concentrate on the angles that we use, our special angles. This one, in case you do find one, it works the same with any angle. So when you're looking for your tangent, if you're looking for your angle, do second tan, find that angle. I converted it into radians since we always answer your angles in radians. They're always in radians, so I just converted this to radians and 3 decimal places. So if you did that, I would not ask you that, and it's certainly not on your final. But know, God bless you, know that there are other angles besides your special angles. But any more questions on this one? Let me just get through this one. Any more questions on this one? Don't worry about it. It works the same. Kids always struggle with this conversion because there's no pi in there. You can still, your radians are regular numbers, so don't worry about that one. Question on this one, Emery? 5 pi over 4. Because your tangent is 1, right? And your angle exists in what quadrant? What quadrant does this guy exist in? When is x negative and y negative? What quadrant? Great. So somewhere down here is my point. So when my tangent is positive 1, it could be down here, or it could be up here. But where is my point? Down here. So this angle is 5 pi over 4. You just have to be careful about your placement. That's why you have to plot that point.
How do you know it's 5 pi over 4?
Because what angle has a tangent of 1? A 45-degree angle. So you know this is 45. So this is 4 pi over 4. So 1 more is 5 pi over 4. It's either going to be a 5 pi over 4 or a pi over 4. But because I'm here, negative x, negative y, I'm in quadrant 3. That's where your positives and negatives are going to come from. Make sure you plot those points. Don't worry about the other part of it. It's just another name for the negative part.
Not the same answer, I'm just gonna assume it's okay.
You're okay?
I think so. Well, instead of using the length, seeing that the radius was 1, because x and y were the same, that's how I got 5 pi.
Yes, absolutely. Because you knew it was a 45-degree angle, and that's fine. Yes. Like most of these are kind of common sense. You can take right off the chart, like right off the graph. You can pretty much plot the point right off the graph, figure out the angle. But some you might just need to do. And 23 again also had one that was not a special angle. Don't worry about 23. And just so that you know, these can be used with non-special angles, non-special ones. So the only thing is, all right. So I need you to do this. I need you to take out your calculator. I need you to take your calculator, and I need you to change your mode. Guys, excuse me. I need you to change your mode to polar. Okay, go to mode. Go past where we did function for parametric, then there's polar. So get to polar, make sure you're in degrees. And once you do that, I want you to hit y equals. Notice what it says, R. What does R stand for? Radius. So all this does is graph a circle. It looks a little oblong. If you want a better look to it, do zoom 5. Zoom 5 takes a little bit of the distortion out of it, so it looks more circle. Now, if I was doing a circle with a radius of 5, what would my circle formula look like in our XY coordinate, in our rectangular mode? X squared plus y squared equals 25, right? So x squared plus y squared equals 25, and it would convert to an r equals 5 to get a circle in polar, okay? So you're going to, because the concept of your polar is just concentric circles, around and around and around. And what changes is your radius. So I need you to keep that in mind when we go through this. That eventually, when we go from rectangular to polar, we're looking at something that says R equals. Okay? And it won't be so bad. Now, we know two things about your X and your Y. We know this one. We know this one. And we've seen this before when we converted to points, right? Okay. So if I'm going to convert to a polar equation, and A can be any number. So if this bothers you, I can put any number in here. I can put a 5 in here if this bothers you. So all we're going to do is this. We're going to substitute in for X. We're going to substitute in for Y. Because when you go to polar, I need to make this the R equals. Okay? I'm going to take this. I got to get my X out of here. So I'm going to say R cosine theta, it is squared. R sine theta, it is squared, equals A squared. Remember, my goal is to solve for R, to get R equals something. God bless you. Because that's what my polar graph says. So this gives me R squared cosine squared, right? When I square R, if I do R cosine times R cosine, if I square this, right? I get R squared cosine squared. Agree? Stay with me. I get R squared sine squared. And this is any number. A is just any number. If you want to, put a 5 in there, put something in there if A bothers you. Now, I need to get R by itself because I need to get something that says R equals. So these both contain an R squared, so I'm going to factor it out. And what is cosine squared plus sine squared? 1. So therefore, I have R squared equals A squared. So I need to get R by itself, so I'm going to take the square root. So normally, R would equal plus or minus A. However, A cannot be negative. Why can A not be negative? Because it's a radius. So R is equal to A. This is any number. And doesn't this make sense to what we just said? If I said your radius was 5, Chris gave me x squared plus y squared equals 25, which is 5 squared, right? So doesn't it make sense that we just put in your calculator? R was equal to 5 when we got this circle? Right? Makes total sense. Put boxes around these guys. This is what you're going to have to use sometimes. These are a little bit more confusing on the equations. So I need you to stay with me on this. If you're talking in between to each other, don't stop me to go backwards. Okay, next one. I'm looking almost the same thing, but what do you think is different? 2ay. So I got the x squared and the y squared, and again I have to get a circle. So what do you think is going to happen here? It's to complete the square thing. I'm not going to have to complete the square, but it's going to turn out with another term in it, right? So it's going to look like your circle formula, but it's going to have an extra term in it that you would have to complete the square to get there. Okay? So now, same process. Put these on top. So wherever we see an x, don't forget this is squared. We're going to put your cosine, your R cosine in here. Okay. All right, so now, let's get rid of your square things. They take a little longer to get through these because you got a lot to like join together, cancel out. we can take this guy and take out an r squared. Do you see the cosine squared plus sine squared in there? So if we get the cosine squared plus sine squared, what does that equal to? 1. So we can kind of eliminate something in here. We kind of have to really look around to take a look at. So maybe it's a good idea to write this one up on the top too. This is a common one that we use. God bless you. Okay, so now I'm going to take this out. Anything else you think I could do? I need to solve for r. Divide. Factor. They both have an r. I can factor. What if they both contained an x? I would factor out an x squared and an x, right? So r is a variable. I'm going to factor out an r. Okay. Now I'm equal to 0. This kind of gives me a little hint. I'm going to take both of these and I'm going to set them equal to 0. Remember how we did this in trig when we had two different functions, but we still were able to take the factors with two different functions and set them equal to 0? Kind of like the same thing. Can we ever have a radius of 0? Nope. We got to get rid of that guy. This guy we're going to put to the other side. I just added it to the other side. Now, a again, a means any number in here. You can put any number you like in there. It'll work for any number. So when we graph this guy, this should give me a circle with something that had like a complete the square in it. So my center is not going to be at the 0, 0 if I had to complete the square, right? If I gave you this, wouldn't you complete the square for this? Like take out the a. Just take the a out of here. Wouldn't you complete this square and then add it to the other side, right? So your center is not going to be at the 0, 0. Agree? So in my polar, I can do it from here. I'm going to come to my polar and I'm going to graph. Let's make AB 5. So let's put, no, that's 10. Let's make AB 4. So let's make this 8. 8 sine. Is that what it was? Okay, so it was 2a, right? I just make AB 4 this way because 2 is going to make it very small. Remember, you're off-centered. Am I off-centered now? Where I would have completed the square, right? So my x didn't change, but my y had to complete the square part in there. Yes? Oh, make your theta go from 0 to 360. As soon as you hit the x, you get theta. Yeah, because what you're dealing with is angles. Your polar goes by angles and radius. So your r is your y equals, and your angle is your x. Make your step like 30. Don't make it too small. Don't put it 0.3 because it's going to take a long time to go through. It will, because you're in polar. It will, because you're in polar. Okay. So good there? All right. Let's try going back.
So how do you get the,
But,
was there like an answer?
yes, it was r equals a 2a sine theta.
Oh, okay.
That was it. A meaning any number. Okay, I'm not going to get the other way, obviously. So tonight's homework, just do the first part